As we mentioned before, there are other candidate keys less suitable to become primary keys and therefore not chosen as such. Instead, they could be designated as unique keys, and product name is a good example of such a key. No two sporting good products should have the same name, but this field is clearly not as good as a product ID because there is a potential that a product name will change. Now, use Notepad again to open up the sixth of the scripts called MySQL 2 6 create product table. Review the script that creates a product table with a product ID as the primary key and some other columns including product name we just discussed, and then using the bottom of the slide in red add the constraint called unique prod name as unique key on product name. Okay, save all the changes, close the script, switch back to Toad, open the script, review it for accuracy, and then run the script to create the fourth table in our sporting goods database called products with the product ID as a primary key, and then somewhere under data columns, there is a unique designation right here. It doesn't appear under constraints for whatever reason. Okay, we'll close these windows and then we'll switch back to the presentation. Okay, now the last three slides of the presentation of the video, and this is the last recording in this particular series, we'll discuss the issues of integrity rule violations and design changes used to fix those problems. We start by taking a closer look at the orders table. Although customer ID, the foreign key, is not part of the primary key in orders table, it still cannot be null because then we would not be able to associate an order with a customer and would clearly violate the referential integrity of the database. To enforce this rule, a not null, right here, is placed following the declaration of customer ID column. Also, we need to add for the employee ID a foreign key to reference employee ID primary key in the employee table and establish that relationship as well. Notice, however, that employee ID foreign key could be null because it is possible that a customer placed an online order not associated with an employee. Again, because the orders table does not have any data, we will try to remove and recreate it just like we did with the customer table in a previous recording. However, switch back to Toad. However, because order table is already related to customer table, you'll notice that if I right click on the orders and try to drop it, okay, the drop should fail. Oops, I guess it did successfully drop. And sometimes it fails, in which case you need to open a script number 7, alter drop order table, and then remove the foreign key. So alter the orders table, it's pretty self-explanatory, and drop the foreign key and then drop the order table. I'm not sure why it let me do it, but it did. So if you don't need the script number 7 for altering the drop, or altering then dropping the order table, it's fine. Just proceed with dropping. Make sure it's dropped though, and then open the script number 8, which is going to recreate the orders table. This time the customer ID after the declaration is going to be not null. Okay, and then we're going to create that second foreign key constraint, FK employee, and you can do this either in directly in the SQL editor or you can do it in Notepad++. It doesn't really matter. Employee ID, just make sure you do it right. Okay, references the employee table and the employee ID. So we're going to save those changes, which will save them obviously on a hard drive. So if you open it with Notepad++, you will see the difference. And then let's run it. Hopefully nothing goes wrong. Order stable is just there with the order ID primary key. And then now if we go to the view details under constraints, there should be two of them. One foreign key referencing customer table, another one referencing employee table. This is the equivalent of those referential integrity constraints in Microsoft Access under Data Build Tool relationships. The two we are talking about is this one here between customer and order, and this one here between employee and order. Okay, switch back to Toad, close both of these windows. Okay, switching back to the presentation. This slide expands on the definition of entity integrity rule by adding that no row can contain a null value for any column in its primary key. This clearly applies to compound keys such as order ID, product ID in the order detail table. We cannot have a null value in either column of the key because if we did, the connection to either orders or product tables would be lost. This leads us to the extension of the referential integrity rule as well. Foreign key that is also part of a compound primary key cannot be null. Clearly, order ID in the order detail table is a foreign key to orders table, but is also a part of the order ID product ID compound primary key, and as such cannot be null. We finish our hands-on work for this video by simply opening and running the script number 9, create order detail table, which will, as you'll sort of notice, create order detail table with order ID and product ID, both integer data types, as a compound primary key. So please notice the line, I think this one here, that creates a PK order detail primary key by combining order ID and product ID in parentheses separated by a comma. And then has two of these foreign keys. One connecting order detail table and orders table on the order ID common field, and another one connecting the order detail table with the product table on product ID common field, just like the Access does with this one and this one. In addition, notice that the on delete or update, we're going to cascade both of those in each of these relationships, which basically means that if the order ID is deleted in the order detail table, it will be deleted as well in the orders table, or the other way around. Okay, and the same applies if we delete a product from the product table. All the deletion will cascade into the order detail table, because you can't have product ID in the order detail table referencing product in the product table that does not exist anymore. Essentially, it's not terribly important right now, but that's what these two mean. Okay, so before we close it, we got to run it. Hopefully, no errors will pop up, and then we'll get the new order detail table showing clearly the compound primary key. And if you right click to view details under constraints, you'll see both connections to orders table and the product table we just described. Close both of these, switch to Access, close the relationships window, and switch back to the presentation. The last slide. Okay, so first of all, let's close all the programs, for now. We'll close Toad, we'll close Notepad, and we'll close Access once I get to it. All right, and then we'll take a breather, because if you went through all this, you definitely deserve it. We went through a lot in this series of recordings that make up this 4th video series, starting with the definition of a relational data model to actual implementation of a simple sporting goods RDM, learning about SQL along the way, specifically create table, primary keys and foreign keys. A number of basic RDM terms were introduced in details, from tables, relationships, various keys to integrity rules and their violations. Next, we are going to talk about a few more concepts such as relational operators, and we will work on adding some data to our tables. Stay tuned.